Assalamualaikum and hi guys, Medium Jasmine here. So today we will learn about torque and power measurement. Okay, so let's start. Okay, for introduction, the power transmitted in rotating systems can be calculated from torque using equation. Okay, torque equals to force times R. So R is the radius of the shaft. Okay, next, what is torque? Torque is tendency of a force to rotate an object and axis. Okay, so from torque we can obtain equation for power, which is power equals to angular speed or omega times torque. Okay, so be careful with the units. The units for torque is Newton meter. The unit for power is watt, and radius should be in meter. Okay, same goes to angular speed is in radius per second. Next, how to measure torque? What is the instrument that we use to measure the torque? So the instrument is dynamometers. Okay, so dynamometers also can use to measure the power. Right? For example, the power produced by an engine, motor or other rotating prime mover can be calculated by simultaneously measuring torque and rotational speed. Okay, so we move to applications. Okay, there are the example of application of rotating system, and we need to measure the torque and power. Car, generator, and pump. Next, we move to detailed dynamometer descriptions. Okay, so what are in the dynamometer? Okay, so 1, 2, 3, 4, 5, 6, 7, 8. So first is engine under test. Second is the coupling. Third is the tachometer. So tachometer gives the reading. And 4 is scale. 5 is torque arm. 6 is the housing. 7 is rotor, and 8 is the trunnion. What types of dynamometers? Okay. So there are 3. First is absorption dynamometer. They are used for measuring power or torque developed by power source such as engine or electric motors. Next is driving dynamometers. These dynamometers measure power or torque and as well provide energy to operate the device to be tested. These are useful in determining performance characteristics of devices such as pumps and compression. And next is transmission dynamometers. They are the passive device placed at the appropriate location within the machine or in between the machine to sense the torque at the location. Okay, so other slide for types of dynamometers. Okay, as we discussed before, transmission types of dynamometers, the power being transmitted to the device is measured. And next, driving type dynamometers. Drive is obtained from the dynamometer itself, or the dynamometer is the power generator. Okay. And C is the absorption type. The mechanical energy is absorbed after it is measured. Okay, so next we move to torsion dynamometer, torque meter or torsion meter. Okay, so this is the strain gauge torque transducer. So as you can see here, during torsion of cylinder, the principal strains, tensile or compressive, exists at 45 degree to the axis. Okay, so apa maksud torsion? Torsion ialah macam pulas, kan? Pulas. So this can be measured by bonded resistance gauge. The output is increased by using 4 gauge. Okay, 4 gauge, so that the adjacent arms have strain, slip rings, brushes in signals in and out of the rotating shaft. And range of torque is between 100 to 100,000 newtons centimeters, and useful for static and dynamic torque measurement. Right? So these are the example of torsion dynamometer. Okay. And next, proximity sensors for torque measurement. Okay. Right. So this is the proximity sensor. So the formula we use in this topic is power equals to omega T. As we know, omega is equal to 2 pi f, so P equals to 2 pi f T. Okay. Two identical tooth wheels are fixed on the shaft on a certain distance. Right? Yang ni yang tooth wheel. Okay, and certain distance. Through proximity sensors, produce output voltage with phase difference proportional to torque. Okay, here are the two proximity sensors, and it will produce the voltage with phase difference proportional to the torque. Right? So the amount of twist in the shaft is proportional to the power. Okay. So next is the belt dynamometer. Okay, in belt dynamometer there is some loss of power due to bending and slipping of the belt. Okay, you all dah belajar ni masa dynamic. Okay. So it consists of endless or continuous belt run over the driving pulley. The driving pulley is rigidly fixed to the shaft of an engine whose power is to be transmitted. A balancing weight is provided in the lever to initially keep it in equilibrium. The weight of suspended mass at one end of the lever balance the difference in tension of tight and slack side of the belt. Okay, so as you can see here, so this is the balancing weight, and driving pulley is rigidly fixed to the shaft. Okay, so here is the formula that we use. mgz equals to T1 minus T2 times 2x. Okay, 2x here. And T output equals to T1 minus T2 times R4. Okay, so which one is R4 is here. Next, we move to gear dynamometer. Okay, so gear dynamometer, arrangement or setup shown in above figure usually used for small power measurement. This figure here. The input and output shaft are coaxial and rotate in the same direction. Okay. The gearbox casing is mounted on trunnions of the shaft to prevent the casing from rotating, and external torque is applied by a mass M at a distance R. Right, so as you can see here, the R is always proportional to the M or force. Okay, so F equals to mg times R. Okay, same goes to this picture. Right. Okay, so Ti is stand for T input. So from this picture, it rotates in clockwise direction, and the output will be rotate anti-clockwise. Okay, so as you can see, T1 is clockwise, the output is anti-clockwise. Right. Next is coaxial rotation. Right, so that's how the coaxial rotation works. Next, we move to the equation involved in gear dynamometer. So the first equation is the output, and output equals to mu T input times N output. So N is speed, T is torque. So torque output, speed output equals to mu T input and N input. So T input and torque outputs are torques on the inputs and output shaft respectively, and the corresponding speeds are N input and N output, with mu as the overall mechanical efficiency. Right. The next equation is T output minus T input equals to mgr. Right. Next, from equation 1 and 2 we get, so simplifikan daripada equation 1 and 2, we get T input equals to mgr mu N input minus N output minus 1, whereas omega is 2 pi N over 60. Okay. Next, you all will do the exercise together with me, but before that, let's finish all the lecture first. So next is driving type dynamometer. Driving dynamometer usually applied in a pump or compressor, where the motor can be used both as a driver and a dynamometer. Usually the DC motor used for this purpose, as speed regulation is easier. This dynamometer measure power or torque, as well provide energy to operate the device to be tested. These are useful in determining performance characteristics of devices such as pumps and compressions. Okay, example, natural gas engine driven air compressor. Next is absorption dynamometer. This type of dynamometer measure torque and power by dissipating mechanical energy, and are suitable for power measurement of engines such as internal combustion and gas turbine engines, and electrical motors, AC and DC motors. This dynamometer measure and absorb the power output of the engine to which they are coupled. The power absorbed is usually dissipated as heat by some means. So for the example is the electrical generator and eddy current type dynamometer, and also mechanical absorption dynamometer. Chassis dynamometer. Next we move to absorption dynamometer. Electrical generator consists of driver, electrical generator, and stator, permanent magnet or electric. Driver drives an electric generator and stator. An arm attached to the stator. Frames to balance the same. The armature supplies to variable resistance that can vary to change the load on the driver. This power absorbed by the dynamometer is then converted into heat, which generally dissipated into the ambient air. And this absorption dynamometer can be used for high power up to 5,000 horsepower or more. Okay, right? So as you can see in the diagram above, the turbine is spin by an external force. This causes a generator to spin and to generate electricity. Okay, next we move to absorption dynamometer, mechanical absorption dynamometer. Okay, so this is a rope brake dynamometer and is used to measuring the power of the engine shaft. From above, it shows a rope brake. One end is connected to a mast and the other one is connected to a spring balance. Due to the rotation, frictional force is generated, so it inducing tension at the two ends of the rope. Right? The friction of the rope absorbs the energy. Heat is dissipated by cooling the rope with water. Next is chassis dynamometer, rolling rod. Okay, so here is the example of chassis dynamometer. Okay, so engine data sends to control console. Okay, and then load data sent to control console. Torque or load sensor transducer. This is torque arm. So this is the driver rollers. Okay, so this power absorption unit. Okay, so this is how to measure the torque and power for a vehicle. Okay, so that's all for chapter 7. Next is doing the example together with me. Right, so after doing the example, I will give you all a tutorial. So thank you for watching and good luck. Assalamualaikum.